that I just want to highlight too. We looked at stuff like this yesterday, and it's like we're solving a system by graphing, okay? A system of linear equations, right? These are both lines, right? And we're going to solve them by graphing, okay? And by solving, when we say solve by graphing, we're looking for the point of intersection, okay? That's what we're looking for, okay? I'm going to do something extra too. I'm going to do something extra with this top section, and then I'll show you guys how we know it's actually the solution and why it is the solution, okay? So sometimes when you look at questions, and I've done this on purpose here, it's going to be, for the purposes of graphing, this one's written nicely, okay? It's written in the form y equals mx plus b, and we've done a bunch of work on this, like on how to graph it, right? How to graph this line. And so I always write this on top, and I'm able to quickly identify what's what, right? So it looks like my starting value, or my b value, is going to be -3. And then my m, or my movement, or my slope, is going to be 2 over 1, right? Okay, and my b value, I'll write it in purple just to stay consistent, is -3. Okay, and where's the -3? The -3 is the starting value of the graph, which always happens on the y-axis. So I go find -3, and it's right here. And then your movement, or how you move around on the graph, is we're going to go up to right 1. Okay, and so I'm going to go up to right 1, up to right 1, and you're just going to keep going, okay? I like to keep going with these questions because I don't know where the graph is going to cross, and I want my line to be as accurate as I possibly can, or as accurate as it possibly can be, okay? And so you can connect this, and I'm just going to take this opportunity to discuss why we draw the back half of the graph, because you don't know, when I draw this other graph here in a minute, you don't know if whether or not the graphs are going to cross down here somewhere, right? And so you need the other half of this graph in case this is actually what's going to happen. It crosses back here, right? And so that's why I was trying to show you, well, the opposite of going up to right 1 would be to go down to left 1. Okay, so that's what you do. You just go down to left 1. Okay, and then you just connect them. All right, and you say, okay, this is the graph y equals 2x minus 3. Okay, that's like that's a nice question because it's written in y equals mx plus b already. You don't have any additional work. You can quickly identify what the slope and the y-intercept are. Okay, we spent a little bit of time doing that, okay, this week. Now, the other thing that we did was like, okay, well, it's great and all fine and dandy if we can plot one line on one graph. But what if there's 2 lines, or 3 lines, or 4 lines, right? You could have any number of equations to graph on one graph, right? And so I'm just going to look at this one. But the problem with this one is it's not written. So if I were to write y equals mx plus b, this is useless to me, right? Like I can't match anything up. It doesn't work, right? And so I'm going to have to take this equation, this one here, oops, and I'm going to have to force it to look like this using some rearranging skills that I've also taught you. Okay, so I want to get the y by itself on the left, right? Okay, well that's fine. So let's take this down here. If I want the y on the left, then I'm going to rewrite this just so I have some room to work. Okay, if I want the y on the left, okay, well it is on the left right now, but it's not on the left by itself like it is in the general form of a line, right? Or y equals mx plus b. And so you're going to do some rearranging here in order to actually make that true. So in order to get the x from one side to the other, we create a zero pair. And what I do to one side, I have to do to the other. Okay? And so then I just clean it up. I get, okay, well, this is now a zero pair. And what am I left with on the left? A 2y is equal to 4 minus x. Okay? Now the y still isn't by itself yet. Okay? But I could divide both sides by 2. And what I do to one side, I have to do to the other. And everything has to be done to the divide by 2, right? And so you end up with this, okay, 2 divided by 2 is now 1y is equal to 4 divided by 2 is 2 minus x over 2. Okay? Now, there is a way to write this so that it actually looks like something you've seen before, right? Like, it doesn't matter the order in which I have these two things, just so long as the sign matches up, right? And so what I'm going to do here is I'm just going to reorder the right side, and I'm going to get y equals negative x by 2 plus 2. Another way to write this here's your equation written in y equals mx plus b. Okay? You can quickly identify, just by writing y equals mx plus b, what the information is that you need, right? Well, b in this question could be 2, and the slope, negative 1/2. Or we could say, we could go down 1, right 2. Where's my starting value? At positive 2. Right? So you say, okay, well, where's positive 2? It's right here. And then your movement, how do you move around on the graph? Well, you go down 1. Right, so you can say down 1, and then right 2. 1, 2. Oh, look at that. Down 1, right 2. Oh, I wasn't even close on that one. So you could be, if you guys know what's going on, you can kind of catch your mistakes if you like miscount a box or something, right? You don't want a line that does this and then all of a sudden does this, right? Or there's a little like curvy blip or something, right? Like, it's got to be a straight line, no matter what, right? So here's what we see. I can connect these dots here on this line. Maybe I'll draw it in black so we can see the difference in the two lines. Okay? And what I'm going to say here is just to illustrate a point. Like, we went through all of this process here to get it to something that we could actually use, right? But there's no difference between this and this up top. It is the exact same equation, just written differently. Okay, it's written differently so that I could actually use it. Okay, it doesn't mean that it changes what's going on, right? So we're gonna go. All right, I can label this this line as x plus 2y equals 4. And what is the point of intersection? Because that's ultimately the question. We're trying to solve this. Remember, we're looking for this point of intersection. Well, where do the two graphs cross? They cross right here. Right? They cross at the point. Remember, it always goes x and y. We go out to 2 in the x direction. So it's 2. And how far up do I go? 1. That's your point of intersection. Does anybody have any questions? Okay, that's almost the same work. It's pretty much the exact same work we've done, with the exception of I was mean this time and gave you like something that wasn't written in a nice form that was useful right off the top. Okay, so you had to do some work to rearrange it so that it was useful. Okay, I don't see any comments in the chat, which is okay. Okay, now, sometimes I don't think we necessarily want to just graph, like we saw yesterday with the cell phone problem. If I don't have nice numbers, like, and the point of intersection is, say, like in the middle of a box, I'm guessing now, right? We don't like guessing, right? We want exact answers, right? In the shortest amount of time. I don't necessarily want to sit here and graph lines all day and have to find grid paper, and like I want to have a process that I can just sit down and solve, right? With just a pen and a paper, and just here's a system of equations and just go, right? That's what substitution is for you. It's the alternative to graphing, right? Now, if I tell you that it's an alternative, we better be able to get the same answer that we just got by graphing. Okay? An alternative means that, like, it's just a different way to get the same answer or the same end result, right? And so when I come down here and I solve this using substitution, which we did yesterday, or you should have started yesterday, right? We should expect to see this answer spit itself out. Okay? And so I'm going to come down here and I'm going to rewrite the equations. Y equals 2x minus 3. And then I get x plus 2y equals 4. Okay, I'm going to move these over a little bit too. Now, the nice thing about a substitution is that this situation is actually preferable where you have two equations that aren't matching in terms of matching. That they're not written both in the y equals mx plus b. Okay? Now, what ends up happening, and if you guys watched the video yesterday, I do this, like, I have there's a bunch of different explanations of how to do this. But anyway, what I like to do is sometimes say, they're shapes, right? And I replace all the x's and y's in a question with shapes. Maybe I'll even do the different colors too, right? I like using squares and triangles. Okay? And so I made the x's the triangles, the red triangles, and then I made the y's a blue square. Okay? And so when I look at these two things now, it looks like, and I'm going to try something here, and I can only try this because I have an iPad. You guys obviously can't do this on a piece of paper. But it looks like one blue square is equal to this piece. It's equal to 2 red triangles take away 3. Okay? But that's just me reading it off. But when we say the word substitution, substitution to me means like replace. Right? Like a substitute teacher would replace your normal teacher, right? And so we're going to if we see that the blue square is equal to this, then I can take that blue square and I can substitute it or replace it where I see blue squares. Okay, so essentially what you can do is take this. I'm going to try and select it. Right? This is what everybody, this is substitution, okay? Verbatim, 100%, there is nothing else going on here aside from what I'm about to show you. It's substitution. You say a blue square is equal to all of this, right? So why can't I take this blue square, what it's equal to, and replace it right there? And now the blue squares are basically going to disappear. That's what's going to happen. Okay? And that looks messy. I'm going to show you again in a second. But I thought this was you're taking the piece that's right here, and it's going in where you see the square, right? And so I'm gonna do, I'm just gonna put this back, okay? And I'm gonna take this equation now, and I'm gonna rewrite it without this blue square here, because I'm gonna replace it or substitute it with what I found it equal to, right? And so I'm gonna get, just bear with me, I gotta draw these red triangles, and then plus 2, but then I'm gonna open up some brackets, right? Because I'm gonna replace this blue square, where it should have been a blue square, I'm gonna replace it with what the blue square was equal to. This. Right? I'm gonna actually take it. Here, let me copy it. See? This is a blue square. I'm going to take what a blue square is. I'm going to put it in where the blue square is. Right here. And that's going to be equal to 4. Right? You can't change. This is still just the equation, except I don't have a blue square anymore. There's your blue square. It's equal right there. Does anybody have any questions? This is very critical. Okay. Does anybody have any questions? You can put it in the chat. You can turn your mic on. Whatever. Okay. It's critical. Again, this is like me moving stuff around on my iPad is new. Like you won't see that in the other videos. Okay. Okay. That's what's actually happened. Right. What you'll notice now is something good in terms of math has happened. Right. I no longer have any blue squares in the statement. They're gone. I'm not going to use blue. I'm going to use black. Right? There's no blue squares there anymore. But if you guys think back to one of the very early days, actually it might have been last Friday, when we were like doing the expansion and collecting like terms, you now just have 2 things there, right? It looks like I have some red triangles that I can clean up, and I'm just going to have some numbers that I can clean up, right? But first, I have to get rid of these brackets that are sitting here, right? So I'm going to have to do our expansion, right? And so I'm going to write the table. I'll be very deliberate here, okay? You guys don't have to do this when you do the questions. I'll go back and do a question with X's and Y's, and it'll be a little bit clearer, okay? Or less, it won't be as time consuming. So you guys do your table. You say, okay, what's 2 times 2? Well, that's 4. 4 red triangles. Okay? And then we say, okay, well, 2 times -3, that's going to be -6. And we talked about the area. Like this is length and this is width, and this is our area on the inside, right? The area is what replaces all of this. You have your length times width. That's equal to area. And so you replace it. You say, okay, we come down and we say a red triangle plus 4 red triangles minus 6 is equal to 4. Right? Now, it's kind of nice because right off the bat, I can see, I can add the red triangles together. But the problem is, I have numbers and numbers. Right? And so you need to figure out, okay, well, I gotta organize everything on either side of the equal sign. So I need all my triangles to be on one side and my numbers to be on the other. Okay? And see, okay, that's fine. I'll create a 0 pair here. I'll add 6. And what you do to one side, you got to do to the other. And so your next line is going to be, you're going to get 4 red triangles. I'll draw the triangle in a sec. Is 10. Sorry, silly me. when you add 4 and 1, that's not 4, it's 5. Right? Is equal to 4 plus 6. I'm just showing you all the work, okay? And I'll add the red triangle. 5 red triangles is equal to 4 plus 6. And so 5 equal to 10. 5 red triangles is equal to 10. How do I get one red triangle? How do I get what one red triangle is worth? You say, okay, I'm going to divide both sides by 5. And I get one red triangle is equal to 2. Does anybody have any questions? I'm going to take a little pause here. Okay. Now, you'll notice that the question called for you to find 2 shapes. Okay? I need to find 2 shapes. I found the triangle, but I have to find the blue square. Like, I still don't know what a blue square is worth. But you guys have something at your disposal. If you just take a look at the original question, you have something that tells you what one blue square is equal to. One blue square is equal to 2 red triangles minus 3. Right? It's right here. It's telling you what it's equal to. All right? So you're like, okay, no problem. Well, I just found what one red triangle was worth. Does that mean I could take it and replace it right here? You bet it does. So now you're going to get, okay, a blue square is equal to 2, open a bracket, what is a red triangle worth? A red triangle is worth 2. So you're going to replace it right there. Times 2. And then you're going to go minus 3. And you just do the math, and it's going to tell you what a blue square is equal to. Right? All right, well, let's do it. A blue square is equal to 2 times 2 is 4 minus 3. A blue square is equal to 1. You've now found what each of the shapes is worth. That is you solving the system, right? Accordingly, right? Using the substitution process. Okay? Now, I'm just going to clean this up and draw a final conclusion, because don't forget about, I don't want to show you, but don't forget when you solve something, we're solving for a POI, right? Or where 2 lines cross, right? And so I'm just going to re-illustrate to you. I'm going to remove the shapes from the original question, right? We found a blue square to be 1. Well, what was a blue square? A blue square was, y's. So look at that. Y equals 1. What was the triangle again? Oh, the triangle was x. What's my point of intersection? It's what's when you combine these two things. Where POI, and remember it always goes x and y, that's 2 and 1. Well, this looks oddly familiar. Where's that from? Well, if I look up at the graph, oh, look at that. That's where the 2 lines cross, right here, at the point of intersection. That's what it means, right? And what this allows for, when you guys can do this work, and I don't expect you to be able to do it, well, hopefully by the end of the day today, but what we can do with this is pretend that like we put some context, like this was time and this was the amount of money that we made or something. You can now provide context around what this point of intersection is, what it means, right? That takes us into word problems that we're going to do next week, right? It's like, here's a system of linear equations. You're going to solve it using substitution and then make sense of it, you know? So, for instance, when I sell 2 t-shirts, I make $1. That's what this does for you. It provides you with an answer, okay, around some whatever situation, okay? If you have 2 lines that look like this, or 2 equations that look like this, you can solve them as substitution, and whatever the words are around these 2 equations, like what we saw yesterday with creating the equations, this is what it means. You just say, I sell 2 t-shirts, I make $1. That's what it means. Okay? Now, I'm going to stop that there, and then I'm going to go back